Welcome to another session of INF 154. So this session is going to be divided into two parts. So in the first part, we are going to focus on the for loop, and on the second part, we are going to focus on the timer. So we are going to start with the list box before the for loop. If you looked at the previous video, you can skip this part of the list box. So a list box, it's a list, it's a control used to store a list or an array of items. So we know that in Visual Studio, it's represented like this, like something like this. But in memory, it's represented as a list of items where every item is stored on a separate memory location, like that. So you have item 0 refers to this block, items 1 refers to the second block, items 2 refers to this block, until items n minus 1. We will get to the meaning of this n minus 1. So how do we add items to a list box? We know how to do that. It's lst.items.add. Then you put the value that you want to add to the list box. This can be a string, this can be an integer, this can be a double, and so on. Let me just do this and do this. Then, as an example, if you say lst, then the name of the list box dot items dot add 10, it's going to add 10 to the first available location. So it's going to add 10 here. So in memory, it's added at items 0. Then when you say lst.items.add maybe hello as a string value, it's going to add that hello at the next available position. So the next available position is this one. So in memory, it's just 1. It's going to add that hello. Then another example, let's say you declare a variable, maybe price equals to 10.5. Then you say lst n.items.add. Then you put that price. Price refers to the variable. We know that the variable stores this 10.5. So it's going to add 10.5 inside your list box. So you are on the next available position. So the next available position is at index 2. So it's going to add that 10.5 to position 2. That's how you add items to a list box. Then let's go to the next part. So in the next part, we are going to see how to access items from a list box. So let's assume that we have the following list box. So this list box contains numbers 10, 30, 50, 60, and 40. We know that in memory it's represented like this, where you have 10, 30, 50, 60, and 40, but you have these dot items. 0 refers to this 10, dot items 1 refers to this 30, dot items 2 refers to this 50, dot items 3 refers to this 60, and dot items 4 refers to this 40. Let's say the name of the list box is just lstn. So in general, to access from a list box, you just say lst, then you put the name, then you say dot items, then you put these square brackets. Inside the square brackets, you put the index. The index refers to the position at which the item you want to access is at. For example, let's say we declared a number, so we know that initially number doesn't contain anything. When we say number is equals to, then when we say lstn.items, then we put 2. We are going to the list box, then it says items at position 2. It refers to this item, so it refers to 50. So it's going to return 50 as an item, as a list item, not as an integer, not as a string, not as a double, but as a list item. So we have to convert this list item to an integer to store it inside num. So we have to convert that 50 to an integer to be able to store it inside the num. That's why we said convert to int32 because on our left we have an integer, on the right we have a list item. So we have to convert that to int32. So when we say lstn.items2, we are referring to this 50, but this 50 is a list item. We have to always convert when we are accessing from a list box. Then another example, we can access and just use it in an if statement. So let's say we want to compare if the item at position 1 is greater than 0 or it's positive. So we can say, okay, if, then we know that to access we say lst n dot items, then you put the position. In this case we are referring to this 30 position 1, but this is a list item because we are getting it from the list box. So we have to convert it to int32 because we are comparing it with an integer. So you have to convert when you are using the relational operators. When you are using the equality operators, you have to convert. So that's why we converted that to 32. So when you say lstn.items1, it's going to go to position 1. So this has 30. So it's going to say is 30 greater than 0. 30 is greater than 0. So it's going to display this message. So the general idea of accessing, you put the name of the list box, then you say dot items, then you put the position. Always. You don't say lstn, then you put square brackets. And you don't say lstn.items.count, then you put square brackets. We will see what .count does. It's not, to access, you just say the name of the list box, .items, then square brackets, you put the position. Then another example, message box.show, then you say lst n.items 4 to 3. So it's going to go to the list box, then it looks at items at position 4. So at position 4 we have 40, so it's going to return that 40. But this 40, it's not an integer, it's not a string, it's not a double, it's a list item. So we have to convert it to string to be able to display it inside a message box. So that's why we said to string, or you can say convert to string, then you put this inside the brackets. Then we are going to move to the size of a list box. So what do we mean when we say the size of a list box? So the size of a list box refers to the number of items in a list box. For example, if we have a list box named lstn, we can say lstn.items.count. This will return the number of elements in the list box. The number of elements in the list box is an integer, so it's going to return an integer. For example, when you say lstn.items.count for this list box, it's going to return how much? It's going to return 3 because we have 3 items. Notice when we say the number of elements, we don't start counting at 0. We have 3 items here. We only count from 0 when we are referring to the position or the index. So in this case, when we return lstn.items.count, it's going to return 1, 2, 3, 4, 5 because we have 5 items. In this case, if we say lstn.items.count, it's going to return 1 because we have only 1 item. And notice the relationship between the last index and the size of the list box. So the maximum index that you can access is always less than the size of the list box. You see here the maximum is 4, the size is 5. So it's always less than. It cannot be equals to or greater than this. You have to take care of that. So how do you access the last item in a list box? So the index of the last item in general, it's just 1 less. You see here we have 3 items. The index of the last item is 2, so it's 3 minus 1, which is 2. In this case the index is 4, which is 5 minus 1, which is 4. in this case we have 1 minus 1, which is 0. So it's always 1 less than the size of the list box. So the index of the list box is just lst n.items.count. So it's always you move from 0, 1, 2, 3 until less than the index is just the size of the list box minus 1. For example, int n, then n equals to convert to int 32. So we have lst dot items. When I see square brackets, I know I must move to this specific position. So lstn dot items dot count. So we have how many items here? 1, 2, 3, 4. So we have 4 items. Then minus 1. So 4 minus 1 is what? This is 3. So this is going to return 3. So we are referring to items at position 3, so which is 4. So this always works. The index, to access the last element, you just put the index of the last item inside those square brackets. Another example is if we try to access, let's say lst.items. At position 4. Notice the maximum index that we can access from this specific in list box is 3. So when we put 4, we cannot access because we don't have that specific position. The maximum is 3 here, so we are going to get an error. So this is a runtime error or a logical error. So your code is going to crash. It's going to compile, but it's going to crash during runtime when it reaches a code like this. So it's an index out of bounds or index out of range. We are going to do more about errors in INF 164, about how to handle errors, exception handling and stuff. But that's the idea of the list box. Now we are ready to move to loops, finally, the for loop actually. So according to INF 154, according to them, not in general, the for loop is a counter-controlled loop. But in real life, the for loop is just an alternative to a while loop. You can have a sentinel controlled for loop. You can have like any for loop, like any while loop can be a for loop. It's just the same thing. It's a matter of preference which one you want to use. But according to INF 154, a for loop is a counter controlled loop. What do we know about counter controlled loops? We know that they depend on some counter. Then we know how many times the loop will execute. That's what we know. So the general syntax of a for loop, you have a for, then open bracket, then you initialize counter, then you have a semicolon, then you have the condition, which is your Boolean expression, then you have a semicolon, then you have the update counter, then you have the task or statements, then you close, then next instruction. This task can be any code. This task can be an if statement. This task can be another loop. It can be a while loop. It can be a for loop. It can be a do while loop. It can be any other code. It can be 100 lines of code. Like this can be like 1 line of code. It can be anything. So how do we execute the for loop? So let's consider the flow chart. So we start at initialize counter, the way we execute the while loop. So we initialize the counter. That's the first thing. And notice that we only execute this code only once. We don't execute it many times. We execute this code once. That's the key point. We don't execute it based on the condition. It doesn't depend on the condition. Whether the condition is true or false, this statement doesn't depend on the condition. It's always executed only once. Then where do we go after initializing counter? We go to the condition. We test the condition. So we are going to test the condition. This is a Boolean expression. It can either be true or false. So if the condition is true, we enter the loop. So if the condition is true, we enter the loop, we execute the task or the statements or the code that we have inside the loop or inside these curly braces. Then after executing the code, where do we go? We don't end the loop. We go back, we go to the update. The way the while loop will be executed, you go to the update. Then after updating, you go where? After updating, you go back and test the condition. So that's how you execute the loop. So you initialize counter, go to the condition. If the condition is true, you go to the task, or inside the loop you update the counter, then you go back to the condition again. If the condition is true, task, update, go back to the condition until the condition becomes false. Then if the condition is false, then you go to the next instruction. If you don't have the next instruction, you stop the program. So that's the general idea. So you start at initialization. This code is executed once, so that one I have to emphasize it. The code is only executed once always. Then you go to the condition. After initialization, you go to the condition. Then you check, is the condition true? If the condition is true, you execute the body of the loop. After executing the body of the loop, don't forget that you go where? You only go to the update after executing the body of the loop. Then after the update, after you have updated, you go back and retest the condition with the updated counter. Then if the condition is true, get inside the loop, update condition. Then if the condition is false, you can exit the loop. Notice that the initialization was only executed once. So this is very important. So now we can move. So we have an example here. Given min and max, write a code that will count from min to max and add the numbers to a list box. So for example, if we have min is 2, max is 5, the result will be 2, 3, 4, 5. Like you are just counting from 2 to 5 and adding those numbers to a list box. So what's the idea? We want to count, for example, normally we just min and max can be any values. So for simplicity, normally you simplify the problem by choosing two numbers, and you ask yourself, what will happen if I choose these two numbers? So what will happen if I choose these two numbers, 2 and 5? So my counter must start at 2, then it must move to 3, it must move to 4, and it must move to 5. My counter cannot move above this 5 because it's my maximum. So my counter must start at the minimum, then it must increase by 1 because we are just counting 2, 3, 4, 5. If it was 2, 4, 6, 8, my counter was going to increase by 2, but in this case we are just increasing by 1. So we want 2 to move to 3, we increase by 1, and so on. So we only add numbers that are less than 6, or if you don't want to say 6, you can say less than or equals to 5. But this 5, we know that it depends on what? On max. So we are going to say less or equals to max. So we start at 2. Then as long as the number is less or equals to 5, we want to add that number to the list box. That's the general idea. Then how do we convert that to code? So we have to declare two variables, min, max. Min equals to 2, max equals to 5. We can get these inputs from a list, from text boxes, or we can get them from numeric up downs. But that's how you would deal with the. So here is just an example. Min contains 2, max contains 5. So our initialization, where do we start the counter? So we are going to start our counter at min. So we said we are starting at min. So that's what I'm doing. Int I equals to min. Then you put a colon, where are we going to stop? We are going to stop when I is less or equals to max. That's what we were analyzing here. As long as that number is less or equals to max, how do we keep counting? We keep counting by saying I plus plus. We increase every iteration. We want to increase I by 1. So let's see. Then what's the task? As long as I is less than or equals to max, what do we want to do? We want to add that specific I to the list box. So that's the general idea. So now and I left a semicolon here. So it's very important. The semicolon is very important. So how do we execute the code? So we start with initialization. So initialization includes these and includes this. So initially, what do we have? Initially, we have our mean, which is 2. Then we have our max, which is 5. So we have our mean and max, which is 2. Then our I starts where? Our I starts at mean. So this initially, our I starts at 2. Then where do we go after initialization? We go to test the condition. Then we check it's I less or equals to max. Is our current I is 2. Then we check is 2 less or equals to max. What's the value of max? The value of max is 5. Yes, 2 is less or equals to max. What do? We execute the code inside the loop. Inside the loop, we are going to add I, which is 2, to the list box. So our list box will contain something like this. Then where do we go after the code inside the loop? We go back to the update. So we have to update the I. So our I will be what? Our I will be 3. So we have to check. After updating, where do we go? We go back to the condition because we updated I. So we have to retest the condition. So in this case, we are going to check it's I less or equals to max. Our I now it's 3 after the update. It's 3 less or equals to max. Our max is 5. Yes, 3 is less or equals to max. What are we supposed to do? We are supposed to execute the code inside the loop. So we have to add I, which is 3, to the list box. So our list box will be like this. So I'm executing based on the code, not based on my knowledge. I'm following the code. So it's important that you execute based on the code. Don't blame the compiler saying that this code is supposed to do this. No, execute the code on paper, then you will find the problem. The compiler is always right because it doesn't write the code on itself. You write the code that you want the compiler to execute. So don't blame the compiler saying, I wrote the code, but I don't know why it's giving me the wrong result. Execute the code on paper. This is very important. If you know how to execute code, then like you are almost done with programming because executing code is very important. Then now we are going to update our I. Our I will move from 3 to what? To 4. After updating, we go back to the condition. We retest the condition. We check. It's 4 less or equal. It's I, which is 4 less or equals to 5. Yes, 4 is less or equals to 5. What do? We execute the code inside the loop. So we are going to add I, which is 4, to the list box. So now our list box will have 3 items like that. Then we do what? After executing the code, we go to the update. I'm not assuming that it's going to go there. I'm following the code I have. I'm not just, unless you become a professor, yeah, there you can just assume that it's going to do like this. But now as a beginner, you have to do it step by step. So my I will increase to 5. Then after updating, where do I go? I go back to the condition. I retest the condition. Then after I retest the is 5 I, which is 5 less or equals to 5. Yes, I is less or equals 5 is less or equals to 5. What are we going to do? We are going to execute the code inside the loop. So it says add that I, which is 5 in our case, to the list box. So we are going to have something like this. Then based on the code, I will go I plus plus. So I'm going to move I to what? To 6. So I have to check, is 6 less or equals to 6? No, 6 is not equals to 6. Then I do what? I stop the loop. So execution of code is very important. So now we can move to the next example. I hope this one makes sense. Now we can move to the next example. So for this example, I'm going to consider one of the problems. So it's problem 7. Let's look at problem 7 and see what's happening. So I'm just going to open it. So I'm just opening problem 7 based on that document. So it was on loops, then 7 is this one. So this is the problem. So we have sum of random numbers. So write a program that will take a number n. So we are going to receive a number n that is greater than 0 and generate n random numbers between 0 and 100 inclusive, and calculate their average and their sum. Also determine the minimum maximum numbers, then number of even numbers and number of odd numbers. Output the sum, average, minimum, maximum, number of even, number of odd numbers on a rich text box. The following figures show how your app should work. So the initial execution, you have something like that: numeric up, down, rich text box, list box, then a submit button. So this is the result when we say number equals to 8. So it's going to generate numbers and add those numbers to a list box. So in this case, n is 8, so it must generate 8 numbers. So let's verify: 1 2 3 4 5 6 7 8. So it generated 8 numbers between 0 and 100, and I see that it's integers, so it's a normal integer like generation. Then after generating, it calculated the sum of those numbers, it calculated the average, it determined the maximum. So as we can see here, the maximum is 54. So this code was able to determine the maximum. Then it also determined the minimum. So based on this code, the minimum is 0. Then the number of odd numbers is 5. Let's verify. So we have 1 2 3 4 5. Number of even numbers is 3. So we have 1 2 3. So it's working correctly. So this is the problem that we are supposed to solve. So when you see a problem like this, don't start by coding. You have to go to the IPO model and all those kind of things. So for me, I won't go to in detail into that. So the first thing that you have to do is to create the form, so you know how to do that. So I have this numeric up down, which is, the name is just txt number, forgetting the number. Then I have this rich text box, name is rtb output, list box, which is lst numbers. Then we have the btn submit for submitting. So you know how to do that by now. So I'm going to double click on the submit. So before I code, what am I going to do? So this is how I made my life easier. So I said, okay, let me divide the problem into smaller sub problems, so that other than just coding everything, yes, if you are good at coding, you can just code everything. But if you are still a beginner, you have to divide the problem into smaller sub problems. So the first sub problems, the first thing that I have to do is to generate numbers and add them to a list box. So that's my first sub problem. So we know how can we do that: add n numbers to a list box. So we just count from 1 to n every time. Then every time we count, we just add a random number to a list box. So the pseudocode or the algorithm, so you have to start start at I equals to 1. If you want, you can start at I equals to 0. You can do it that way. You can experiment with that. But for me, I'm just going to start at 1. Then as long as I is less than or equals to n, what am I going to do? I'm going to generate a random number and add the number to a list box. Then after that, I just update counter, increase counter by 1. Since I'm just counting, if n equals to, let's say, 3, I have to add 3 numbers. How can I do that? I'm going to count from 1, 2, 3. Then at 3 I stop. So that's why I said I'm starting at n equals to 1. I'm stopping at n less or equals to 3 or less or equals to n here. So if you start at 0, 0, 1, 2, so you must start at n at less than n, not less or equals to. You must start at less than n. You must stop actually at less than n. You must start at 0, stop at less than n. If you start at 1, you must start at 1 and stop at 3 or at n. So after that, you just go back. As long as you didn't reach the end, you just keep repeating the same process. So this is a loop. So let's see how it works with a for loop. You can use a while loop if you want, but in this case now, I'm just going to use the for loop since the focus is a for loop. So I'm going to start. Let me see. Let me zoom here. So I'm going to get inputs from the user. What do we need? We need a number. So I'm just going to get inputs from the user or declare variables, whatever. Declare variables. Then to generate random numbers, I'm going to need we know the general process of generating random numbers. We need a number, so you must have a number, maybe random number, whatever. Then you must, let me just initialize it to 0. Again, for random numbers, you must have a number, then you must have a random number generator. So let's say random, you know how to do that by now, equals to new random. That's the random numbers part. That's what you need to generate random numbers. Then for the input, I only need the number. N equals to, I'm getting the number from a numeric up down. So nud. So didn't I name my numeric up down? Or maybe I made a mistake by saying txt. Yeah. So let me just say nud. So now I can say nud number dot value. That's how we get the value from a numeric up down. But on my left I have an integer, on my right I have a decimal. So I have to do what? I have to convert to int 32. So that's important, converting. Then now I'm good to go. Instead, I was just, if I wanted to separate my code, I was supposed to say int n equals to 0 for initialization. Then this one can go like, if I was concerned much about separating variables from inputs, this is what I was supposed to do. Then now I can go to my process. So the process, we are just going to follow that pseudocode or algorithm. So we said we are going to start where int I equals to 1. So we start counting from 1 according to what I was doing here. We start counting from 1 until what? I is less or equals to n. So until I is less or equals to n. So I is less or equals to n. Then how do we count? We just increase I by 1 every time. Then after that,